Okay, in this video, we're going to be doing some trig practice. So let's start with this problem. Solve the following equation on the specified domain. So to start with this, we're going to write this as cosine squared of x plus cosine of x is going to be equal to 1 minus cosine squared of x. And the reason is because of the Pythagorean identity. Cosine squared plus sine squared of x is equal to 1. This is a Pythagorean identity that you just have to know. And if you rearrange it for just sine squared of x, that's just going to be 1 minus cosine squared of x. So you just sub that in right here for that. So from this, we can say, So from this, we just rearrange it. So we can just say change my pen color. 2 cosine squared of x plus cosine of x minus 1 is going to be equal to 0. And now we're going to do this thing called U substitution. In U substitution, you basically use it so that you can you can do factoring, or you can do the quadratic formula. But here we're just gonna do factoring. So we're basically going to say u is equal to cosine x. And you're basically, when you do U substitution, you want to set u equal to something that would act as a variable in which you would be not distracted. You're trying to remove your distractions so that you can factor the expression to make it more simple. And then later we're going to substitute the value that we plugged in for u back into the equation. So from this, we can imagine u is there. So we can rewrite this as 2u squared plus u minus 1 is going to be equal to 0. So we can factor this by shifting that. U squared plus u minus 2 is equal to 0. So u minus 1 u plus 2 is going to be equal to 0. Now divide by 2. Now you have u plus 1 is equal to 0. And then you have 2u minus 1. And from here, u plus 1, sorry. And then you can just substitute cosine x back for u. And when you do this, you get 2 cosine x minus 1 is going to be equal to 0. And then we rearrange it for 1, and then we have cosine x divided by 2, blah, blah, blah. Yeah, so you have cosine x is equal to 1/2. And we ask ourselves, when does this occur on the unit circle? And this would be at 5 pi over 3 and 7 pi over 3. Now we're going to do this for the second solution as well up here. So that's going to be substitute cosine x back in, and you have cosine x plus 1 is equal to 0. And then you have cosine of x is equal to -1. Now x is going to be equal to pi, and we know that's our solution. And then we can box our solution in. Perfect. Okay, that's not a rectangle. So, now we're going to move on to our next question. Secant functions can be written in the form y is equal to a secant b x plus c plus d. And cosecant functions can be written in the form of a cosecant b x plus c plus d. Write a secant and cosecant equation for f of x graph below. So what you need to know is that typically on these graphs, always the graph of secant will almost bounce off. It's kind of gonna bounce off of the graph of sine or sorry, yeah, of sine. Cosecant is going to bounce off the graph of sine x. So let's say that sine x is going to be, sine x is going to be like this. And then that means that, I don't know how to write this, I don't have room. Cosecant x is this. So cosecant x is kind of going to look like this. It's going to bounce off. So that can help you write, if you need to write the cosecant and sine x equation, it's kind of going to be like a shift. But here they're asking for secant and the cosecant. So this might be a little bit difficult. You may want to find like find for cosecant you might want to find sine of x, and for secant you might want to find cosine of x, but here we're just gonna jump straight to it. So first, like, we have the graph, so we can just like do it because it's gonna be the same for all trig functions. So we know that the formula for the period is 2 pi over b, and here we can identify that the period is going to be just from like pi, just from here, yeah. So that means we can set the period is equal to pi over, that is not the period. The period is the full graph. So one period is defined as like when the graph starts repeating again. So that's like what it means like periodically. A period means like a full repetition of the pattern of the graph. So that's just going to be like this whole portion right here, and this length is going to be pi over 2 length. So we set the period is equal to pi over 2 pi over b. So now we're solving for b. So solving for b, we get that we can cross multiply this. B pi is equal to, or we can just, so we can just get that b is equal to 4, and then we have the a is going to just equal to 1. The amplitude is just going to be the height, and here you can see that a is just equal to 1, and the d is going to be equal to 0, because we know this because this is going to be, for this we can see that the shift is going to be 0. And let's see, what is our natural graph here? This is going to be let me do this in blue since we made sine blue earlier. This is going to be a sine x graph, because we know this is a sine x graph because of the fact that it's like starts here, makes like a S when it crosses with the x-axis. So we can write the secant x equation. Think of like cosine x for this, and the sine x equation. We can write the cosecant x equation and the secant equation. Start with this. F of x is just going to equal to secant 4 x pi over 8. Minus pi over 8. And we know this because like for this, I'll highlight the points when we're done. Or another variation is going to be f of x is equal to negative secant. So that's going to be a vertical reflection, 4x minus 3 pi over 8. Yeah. So for this, like, look at, for pi over 8, like, look here. That's where it's, like, starting. And then for 3 pi over 8, just imagine that that's where it's starting. So that means it would, like, start down there because it's going to be a vertical reflection. So it would be, like, shifted, like, think, like, opposite. And then for cosecant x, this would just be f of x is equal to cosecant 4x, or a variation would be f of x is equal to negative cosecant 4x minus pi over 4. So for this, you can see negative pi over 4 is going to be this, or yeah, and yeah, or just like literally 0 for, let me highlight this. There's no like shift in here, so I guess it's like, imagine that right there. So yeah, that's basically it. Hi, so in this video we're going to be doing some more trig review. So let's start off with question 1. Let g of x equal to tan of x times secant x. Rewrite g of x as a fraction involving powers of sine x and no other trigonometric functions. So this is going to be equal to sine of x, tan of x is going to be equal to sine of x over cosine of x, and secant of x is going to be equal to 1 over cosine of x. And rewriting this, we can multiply cosine of x. That's going to be sine of x over cosine squared of x. And this is going to be just equal to the Pythagorean identity. Yeah, so you have cosine squared of x plus sine squared of x is equal to 1. And if you just solve for cosine squared of x, that's going to be 1 minus sine squared of x. So then if you plug that into the our expression, then we have sine of x is divided by 1 minus sine squared of x, which is right here. You can see that. Okay, so now let's move on to our next question. Let h equal to 1 minus cosine squared of x divided by cosine squared of x. Rewrite h of x as an expression involving tan of x and no other trigonometric functions. So we are trying to get this as our target. So this means that we're going to set this equal to, we know that this is another Pythagorean identity, 1 minus cosine squared of x. So again, you can like, I'm just going to write this like over here. Cosine squared of x plus sine squared of x is equal to 1. And then you're going to solve for, we're going to subtract cosine x from the other side. So yeah, this is going to be 1 minus cosine squared of x. Yeah, so you can see this was the expression right here. So, yeah, you can just substitute that in right there. So that's going to be sine squared of x divided by cosine squared of x is going to be equal to, now you can factor, you can like remove the squared from both the numerator and the denominator and put that in a parentheses on the outside. So sine of x over cosine of x, and you put that in a square, and then you can see that sine of x over cosine of x is just tangent of x, and then you just add back the square. Now, okay, we can box this in actually, and box that in too. Now let's move on to our next problem. So we have let f of x equal to 1 minus secant squared of x divided by sine squared of x. Rewrite f of x as an expression involving secant x and no other trigonometric functions. Okay, so what this means is we're going to start off, this is another trigonometric identity. So we know that, what is it? Yeah. So another trigonometric identity that we know is 1 plus 1 plus tangent squared of x is going to be equal to secant squared of x. So solving for just tangent squared of x is going to be equal to secant squared of x minus 1, or yeah, or it's going to be like negative, or if you just like want in the other form, it's going to be negative, but tangent squared of x is equal to 1 minus secant squared of x, I'm pretty sure. Yeah, so yeah, you're just gonna sub in negative tangent squared of x and divide that by sine squared of x, and that's gonna be equal to you can rewrite, we're gonna target tan of x. So tan is just gonna, you always know tan is just sine of x over cosine of x, and then you can write that as a square on the outside. And then now we're gonna target well, we can just like, we just need to finish like, okay, this looks like the same color, but like let's just target like this part right here. So you're just gonna write that as like, you know, the fraction that it was already, you know, the thing of, but just like alone, and then you have that right there now. So like I'm gonna write this down here because it's kind of running out of space. So now you can, okay, let me highlight that so that you can remember. Okay, so now you have negative 1 over cosine squared of x, and then because like you can see that this cancels out and this cancels out, because you know that if the square goes back in, like that would cancel out, and then that's just a common factor. Yeah, so you have negative 1 divided by cosine squared of x, and you square that, and then you're gonna have negative secant squared of x, because yeah, you can distribute that back out, and then you just replace that with secant of x. Okay, now to our next question. Let k of x equal to cosecant of x times tangent of x. Rewrite k of x as an expression involving secant x and no other trigonometric functions. So in order to do this, we know that cosecant of x is equal to 1 sine of x, right? So we know that it's equal to 1 sine of x, and we know that tangent of x is equal to sine of x over cosine of x. And so we can just cancel out the common factor right there, and then we have 1 cosine of x is equal to secant of x. Okay, so that was pretty simple. And can box last problem. Okay, that's not a box, but you know. Okay, and move on to our next problem. Let j of x equal to secant x times cotangent of x times tangent squared of x. Rewrite j of x as a fraction involving powers of sine x and no other trigonometric functions. Okay, so in order to do this, we have 1 over cosine of x times 1 over tangent of x, because yeah, so secant of x is just 1 over cosine of x. Cotangent of x is just 1 over tangent of x. And tan squared of x, we're just going to keep it as that for now. Okay, so now we're going to rewrite this as tangent of x over cosine of x. Reason being, we can cancel one of these tans and because of the common factor, and we keep the cosine of x. And now we're going to target just the tangent of x. So the tangent of x is just going to be rewritten as sine of x over cosine of x. And then you can rewrite this, just move the 1 cosine of x over here. You already had that. So yeah, blah, blah, blah. So now this is going to be equal to sine of x divided by cosine squared of x, because you have to multiply these two. And then that is going to be, and we know that cosine squared of x is, according to the Pythagorean identity, cosine squared of x plus sine squared of x is equal to 1. Yeah, so you just solve for cosine squared of x. That's just going to be 1 minus sine squared of x. So then you have sine of x divided by 1 minus sine squared of x. Perfect. Box your answer, and let's move on to the next question. So 6, let m of x equal to cotangent of x times cosine of x divided by cosecant of x. Rewrite m of x as a fraction involving powers of cosine of x and no other trigonometric functions. So cotangent of x, you know that cotangent of x is going to be cosine over x over sine of x. And then you know that cosine of x, yeah, you just write cosine of x again, just for the sake of like keeping organization. 1 over cosecant of x is going to be 1 sine over x, and you can rewrite this again. Let's when you divide by a fraction, same thing as multiplying by that fraction reciprocal. So you have cosine of x over sine of x, yeah, multiply that, and then you have cosine of x times sine of x, and then what is this equal to? You see this common factor right there, and then we just multiply those two. Is going to leave us with cosine squared of x. So box our equation, and then we're done. Okay, let's up here. Okay, so the figure shows 2 circles centered at the origin with angle measures of alpha and beta respectively in standard position. The terminal ray of angle alpha intersects the circle at point P, and the terminal ray of angle B intersects the circle at point Q. The points P, the coordinates of P are 4, 3, and the coordinates of Q are 5, 12. So find 2 times alpha. So sine 2 of alpha, this is just going to be, you're going to use this formula. So that's just going to be 2 sine of alpha times cosine of alpha. So that's going to be 2 times 3 over 5 times 4 over 5. And and that's going to just be 24 over 25. Great, you can box that answer. And yeah, now find sine alpha plus beta. So sine alpha plus beta, that is going to be the formula sine alpha plus cosine of, okay, this is kind of running out of space, so I'm gonna write it down here. Sine alpha cosine of beta plus cosine of alpha sine of beta. So that's just gonna be equal to 3 over 5. And then this is going to be 5 over 13. And it's going to be 4 over 5. Okay, wait. 4 over 5. And then this is going to be 12 over 13. And then just adding everything together, that's going to be 15 over 65 plus 48. Oops. Wait, that looks weird. 48 over 65. And that's going to be 63 over 65. So that's going to be your final answer. Then you just box that. Okay, now let's do find cosine. Okay, you're supposed to be like looking at like these, by the way, like to like figure out the ratio. So you can figure out this is 5. You figure this out like from the fact that like that's 5. This is 3. Here for beta, this is going to be, okay, wait, that's not exactly 5, but like just like you can drop the altitude down and like you just see that. So that's at 5. Yeah, that's 12. And then this is at 4. And then this is at height 3, I believe. Yeah, that's going to be 5. Sorry, this is going to be 12. Sorry, this is going to be 13. This is going to be 12. Yeah. That's essentially how we're finding like the ratios. So, minus, this is going to be equal to cosine alpha times cosine of beta plus sine of alpha times sine of beta. So this is going to be equal to 4 over 5 times 5 over 13 plus 3 over 5 times 12 over 13. And this is going to be equal to 20 over 65 plus 36 over 65. And this is going to be equal to 56 over 65. Yeah, so you can box that in. And up here, we're just going to write like what the values were. Sine of alpha, this is going to be the ratio of 3 over 5. And then, yeah, so cosine of alpha, that was just the ratio of 4 over 5. And then sine of beta, that's going to be 12 over 13. So you actually want to do this before you do the problem, but you know. Cosine of beta is going to be equal to 5 over 13. And you know this because like opposite over hypotenuse, adjacent over hypotenuse, opposite over hypotenuse, adjacent over hypotenuse. And yeah, I'm just going to highlight these for you just to see visually. This is going to be blue. Okay, opposite, yeah, it's going to be 3. And then this is going to be hypotenuse right there. And then this is going to be, let's make this opposite. 12, that's 12 right there. And then this is 13. That's going to be 13 right there. And then, let's say over here we have hypotenuse again, 5, 5. 5A, 4, yeah, And, okay, wrong color, 5. And yeah, okay, let's move on to the next question. So this is basically the same thing again. So we're going to start with sine of alpha. This is going to be equal to what? So we can drop an altitude and basically pay attention to this because that basically tells us the length of the, what is it? Yeah, the length of it, the radius of the circle. So from here we can figure out that sine alpha is going to be root 5 over 3. And then cosine alpha is going to be equal to negative 2 over 3. And then for beta, we can figure out that it's going to be sine beta is equal to root 7 over 4. And then cosine of beta is going to be equal to 3 over 4. So let's highlight these on the circle thing. Yeah, so again, just write down the ratios, what they represent, and then yeah, so what color should we use last time? Okay, purple for, let's just write purple for our hypotenuses. And then we have our opposite here. And then opposite, that's going to be just this for theta. Purple is going to be hypotenuse for here. And then this is going to be our adjacent side, so that's going to be right there for this. Now we can write these. So to find cosine 2 alpha, that is going to be 2 cosine squared alpha minus 1. And then this is going to equal to 2 times negative 2 over 3 squared minus 1, which is going to be equal to 2 times 4 over 9 minus 1. And it's going to be equal to 8 over 9 minus 9 over 9. It's equal to negative 1 over 9. Box our answer. Okay, now we can move on to the next one. So sine alpha minus beta. This is going to be equal to sine alpha cosine beta minus cosine alpha times sine beta. Okay, so now you just have root 5 over 3 times 3 over 4 minus negative 2 over 3 times root 7 over 4. And then let's just simplify this down. Now we have 3 times the root of 5 over 12, okay, plus 2 times the root of 7 divided by 12. And then this is going to be equal to 3 times root 5 is 2 times root of 7. And then you divide that over 12. Yeah. Okay, so now cosine alpha plus beta, this is going to be equal to cosine alpha plus, times cosine of beta minus sine of alpha times sine of beta. So this is going to be equal to negative 2 over 3 times 3 over 4. And this is going to be negative, that's going to be root 5 over 3 times over root 7 over 4. And this is going to be equal to negative 6 over 12 minus root of 35 over 12. And this is going to be equal to negative 6 plus the root of 35, all divided by 12. And that is going to be your final answer for this. Let's continue with question 13. So to solve this, which of the following expressions is equivalent to 4 cosine 2 of x? We're going to use the double angle identity, which is cosine 2 of x is equal to 2 cosine squared of x minus 1. And rearranging this, we get 1 minus 2 sine squared of x. So, and just plugging in. Now we can use 2 cosine squared of x minus 1, and we're going to have 4 cosine 2 of x is equal to 4 times 2 cosine squared of x minus 1. And this is going to be equal to 8 cosine squared of x minus 4. So this is going to be option D. Let's use this to highlight. Now, which of the following expressions is equal to sine x plus cosine x squared? So we are first going to start with expanding the square. Sine x plus cosine x is the same thing as this expanded form. Now we're just going to FOIL, and we get sine squared of x plus 2 sine of x times cosine of x plus cosine squared of x. And we can use the fact that we see right here, this is a part of the Pythagorean identity, that sine squared of x plus cosine squared of x is equal to 1. And yeah, so we just replace that with 1. we just cancel out and replace that with a 1. So here we go. Highlight this, highlight this. That's all going to be 1 plus 2 sine of x times cosine of x. Now, we can use the fact that sine 2 of x is going to equal 2 sine of x. This is another identity that you have to know, cosine of x. So by using this, we can further simplify this. You highlight this to remember. So that's going to be 1 plus sine 2 of x. And this is answer option D right here. So we have our answer. Okay, so where x is not equal to 0, which of the following is equivalent to cosine squared of x minus 1 divided by cosine squared of x? So we can start by rewriting the numerator as this. So we see that cosine squared of x minus 1, we can factor out negative 1, and we're left with 1, which just becomes positive, and this becomes negative. So negative cosine squared of x. And we can rewrite this also as, we can just keep that over cosine squared of x. And then we can also rewrite this with the Pythagorean identity. As we know, again, sine squared of x plus cosine squared of x is equal to 1. So we know that if we solve for sine squared of x, that is just going to be 1 minus cosine squared of x. And we see 1 minus cosine squared of x right there. So we can replace that with sine squared of x. That's going to be negative sine squared of x. And that's going to be divided by cosine squared of x. And sine squared over x was cosine squared over x. That's just going to be sine over cosine. You see that? This is just tan. So, yeah, and you have the negative sign. So that's just going to be negative tan squared of x. And this is going to be answer option C. So, okay, now let's move on to question 16. Which of the following expressions is equivalent to 1 plus cotangent squared x times sine squared of x? So recall the identity that 1 plus cotangent squared of x is going to be equal to cosecant squared of x. So we can write that we have 1 plus cotangent squared of x. So we can replace this cosecant squared of x. That's cosecant squared of x. So we have cosecant squared of x times sine squared of x. And we also know that cosecant x is just the same thing as 1 sine squared over x times sine squared over x. And this is a common factor in the numerator and denominator, so that cancels out. So we just end up with 1. Now let's move on to our next question, which is equivalent to 3 sine 2 of x. So let's start with this. We can remember that sine 2 of x is equivalent to 2 sine of x times cosine of x. So we can rewrite this as 3 sine of 2 of x is going to be equal to 3 times 2 sine of x cosine of x. And this is going to be 6 sine x cosine x. And this is equal to option C. So now for our final question, which of the following expressions is equivalent to cosine 5 pi over 9 times cosine 3 pi over 9 minus sine 5 pi over 9 times sine 3 pi over 9? So we can recognize that this is the cosine sum identity. This is the cosine sum identity. So this is just cosine A plus B is equal to cosine A times cosine B minus sine A times sine B. So now that we have this, we can rewrite this entire expression as cosine 5 pi over 9, as we can identify, we'll just finish writing this, 5 pi over 9 plus 3 pi over 9 is equal to cosine 8 pi over 9, because you can just add the numerators and keep the denominator. And so this 5 pi over 9, this was A, and this was also A, and then this B was right here. So yeah, and cosine 8 pi over 9, well, that's just answer option D, and we are finished. Thank you.